Hello everyone, this is Jinju Wang. Today is the session 2 of Python for geospatial analysis. In this session, we will hand make a GeoTIFF file. This session includes 3 parts. We first manually save images as numbers, and then we manually create coordinate system information for the image. Lastly, we will use Python to save these numbers to a GeoTIFF file. Okay, let's get to the first task. Save images as numbers. This is a smiling face I found online, which I feel very interesting. The coordinate for this image, the latitude and longitude, is as here. So let's go to Google Earth and see if we can find this map. Google Earth. Let's get to the Google Earth. So here, let's paste in the coordinates we just found. Okay, it will lead us to this smiling face. Let's zoom out to see the big picture. So we can see that this smiling face is in Canada, and it's near Toronto, near the US-Canada border. Let's zoom in and see this photo again. In order to handmade this photo, we first need some measurement. We need to know the height, the width, and the top left corner of this image. Let's measure the height first. We can see the height is around 40 meters. Okay, that's good. And let's measure the width. The width is also 40 meters. For simple task, we just think this image is 40 by 40. The next piece of information is the top left corner of this image. Let's hit here and get info. We can see that the top left, the latitude and longitude is this number. Okay, for simplicity, I've pasted this image here, and I've also pasted the latitude and longitude here. Now we get the necessary information for this photo. There's still one more mission we need to finish. We know here the height and the width is 40 meters, but the original top left coordinate is in decimal. So we need to somehow transform this decimal coordinate into coordinate that has the unit of meters. I've done here. I can paste the URL here. This is the transformation online. So we basically just copy. This is the latitude. And we know the latitude and longitude is WGS 84. What is WGS 84? You just think of it as the name of a coordinate system. And the longitude is -8a. We want to transform the decimal in WGS 84 to Web Mercator. Web Mercator, the unit of Web Mercator is meters. So let's hit convert. So let's copy here, put it there. Okay, we finished this piece of information. We successfully transformed the decimal coordinate into a XY meters coordinate. And the name of the meters coordinate is Mercator. But a more common use, most of the softwares using this EPSG 3857 to indicate the Mercator. All right, now we finally finished all the information. The top left corner, the height and the width of the image. We can start our job. First thing first, let's create a grid cell covering the whole image. This grid cell is 20 by 20 That means each cell is 2 meters long and 2 meters wide. Let's manually type in 0 and 1s in this photo. I mean, whenever we hit the smiling face, we change the value to 1, and whenever it's not smiling face, we change the value, we use the value of 0 to indicate everything. So we are truly handmade this photo from scratch. Okay, I will do this job and finish up and start recording again. Okay, now I have finished filling the cell values to covering this smiling face. Now we can start creating a Python project to make these numbers 0 and 1s combine with its height, width, and top left coordinate to make it a GeoTIFF file. Let me go back to my desktop and create a new folder. The folder name is session 1, and inside this session 1, let's create a new Excel file. Smile, give a name smile. Open this smile empty Excel file. Let's copy all the values from this grid cell and copy everything back to this Excel file. So let's zoom in, let's resize each grid cell so it looks like more of a rectangle. Now, because it's 0 and 1s, we can give it some color. We can choose this conditional color and this one. So here you can see something funny, really funny. Let's copy this one and paste it to the screen. Magically, we have manually create a smiling face using only 0 and 1s. So that's essentially is telling us that an image is basically just some numbers. To make things easier for Python, we need to save this Excel file to CSV format. Let's choose File, Save As, and save it as CSV UTF-8, and hit Save, and close this file. Let's go back to the session 1 folder. Alright, we don't need this Excel file now, so we can remove it. Now, let's go back to our VS Code. We can drag this session 1. Please make sure you click this Explorer. We drag the session 1 to this Explorer, and let's maximize VS Code. We can also see Smile inside here. That means we have now linked the VS Code to the CSV file. Now, let's start coding. Let me make this a little bigger so you can see it more easily. First, we create a folder and give the folder name data. And let's drag and move the CSV Smile to the data folder. I'm doing this is to separate code from data because we don't want to mix everything together. And then we create a new file with this tab. We give it a name, save number to image.py. Now, VS Code will automatically open this file. And here, to read CSV file, we need NumPy. We need pandas, P-A-N-D-A-S, as PD. Let's execute this line. So I move my cursor to here. Remember that in the session 1, we changed the keyboard binding by holding Shift and Enter. It should send this code to an interactive environment. So let's hold Shift and Enter. Well, it's not. What happened? The reason for that is we have created an Python environment, but the VS Code cannot find or is not using the environment we are creating. Let's hold Control, Shift, and P. and type in interpreter. And let's select this Python select interpreter. It will pop out a terminal asking us which environment we want to use. So we want to use this one because we create this one for this course. Let's hit this one. Now, below this tab, you can see Python is using VS Code is using Python from this Geo environment. Okay, now let's hit Shift and Enter. We can see that this code is automatically copied to this interactive window, and it will execute there. But before that, VS Code is asking us, it has not found this IPY kernel package. So what we really need to do is to install this IPy kernel. We can simply hit install from here, and VS Code will smart enough to find this package and install for us. Now, let's close this interactive window and rerun this code. Shift and Enter. It tries to run this code, but it says module not found. No module named pandas. Well, that's reasonable because we have not installed pandas now. To install pandas to this GOENV environment, we need to pull out this terminal. And first thing first, calm down, activate GOENV, then calm down, install pandas. Okay. Now I can see the installation is successful. Let's run this code, Shift and Enter. Okay, it's running. That's a good sign. Okay, we see this successful sign. That means this code has been successfully executed. Now we have a successful environment and a pandas package to use. Let's read the smile CSV file, and let's give it a name, smiledf equals to pd read CSV. By the way, if you can see that VS Code is always suggesting some code for me, and I can just simply hit tab to complete the suggestions. That is because I'm using GitHub Copilot, which is an AI tool to assist me to coding. If you want to use that, you can enable or install GitHub extensions. And now, smiledf equals read CSV. We need to provide the correct file path. Let's go to the data folder, right-click, copy relative path, and replace here. And yeah, before that, please make sure your save num to image.py file is not inside this smile CSV, because we are using relative file path. It's very important we're not messing around the relative position. Okay, let's close this Explorer for a moment because we need more space. Now let's execute this smiledf. Okay, the smiledf is now loaded to Python. We can highlight this smiledf and then hit Shift and Enter. That means we only execute this part of the code. Now we can see those CSV numbers from here. We can even check the size of the smile shape of the smiledf, see how many rows and columns of it. Here it says it only has 19 columns, but remember the number should be 20 columns and 20 rows. What happened is Pandas is using the first row as column names. So when reading smiledf, we need typing headers equals now. This is to tell Python, do not use this first row as the column names. Let's re-execute this column, and then print out the shape. Okay, now we got the correct shape. We know the df is 20 rows and 20 columns. Let's see the numbers. Zoom out a little bit. Okay, that's more like it. We now successfully load the number we just handmade into Python. Okay, this is the end of session 2, the first half part. In this session, we copied this image from Google Earth. In Google Earth, we get the coordinate top left corner. The degree is 43 and 80 somehow. Next, we measured that this image is 40 meters long and 40 meters wide, and we transformed the top left corner from degree to meters. At last, we overlaid a grid cell on top of the smiling face and using zeros and ones to manually indicating the smiling face. Last, we copied the smile CSV to a folder and use VS Code, opened this folder, create a new Python file. In the last, we read this CSV file into VS Code, and we solved a little problem, which is the heading problem. This is the session. In next session, we will explain how we can save these numbers to a GeoTIFF file.